Okay guys, this set of notes is going to go over energy and the different types of energy, as well as energy transformations. So the cool thing about energy is it never really goes away. It either transforms or changes from one form into another, but energy is never really lost. There is something we call the law of conservation of energy, and this states that energy can neither be created or destroyed. Instead, it will just change form. So for you to know the different forms that it can change in, we have to talk about the different types of energy. The first type of energy is potential energy, which we will abbreviate as PE. And this is the energy that an object has because of its position or condition. So if it is something that's on top of a hill and it's about to roll down the hill, then it's said to have stored energy. So potential energy is stored energy because it has the potential to release the energy and start moving. So up on the hill here, it says that this is the highest amount of potential energy because it's reached the highest point to where it's about to release all the energy that's stored within it. And then here it says something about kinetic energy, which is our energy of motion. So kinetic energy is the highest once it's gained all of this movement energy and then it hits the bottom of the hill. That's when kinetic energy is at its highest. So potential is our stored energy and kinetic is our energy of motion. There are two different types of potential energy that you guys are going to be held accountable for. The first is elastic potential energy, and this is stored energy that's associated with something that's spring-like or compressed. So I know you can't see that word right there, so I'm just going to spell it out for you. Compressed. An example of elastic potential energy is kind of like a slingshot here. If you pull it back, it's elastic, so it stretches, and once you pull it all the way back, it's got all this stored energy until you release it. So that is elastic potential energy. The other type of potential energy is gravitational potential energy, and this is stored energy as well, but it's based on its position. So, for example, gravity is going to be pulling it down. And if you look at this picture right here, it shows a skier at a lower hill, and then another skier at a higher hill. And the skier that's at the higher hill has more gravitational potential energy because he's at a greater height. He has more energy to release because the hill is higher. So that is gravitational potential energy. Kinetic energy I mentioned earlier when I talked about potential energy. Kinetic energy will be abbreviated with KE. And this is our energy of motion. So if something's moving, it's said to have kinetic energy. Now, the amount of kinetic energy is going to depend on the mass of the object and the acceleration or velocity of the object, so how fast it's going. We typically look at examples with a roller coaster to look at the difference between kinetic and potential. So as I mentioned earlier, your kinetic energy is going to be the highest right here when that roller coaster is at the bottom of the hill because it's gained all this energy going down, and so it's highest at the bottom of the hill, kinetic energy is. If you notice, potential energy is our stored energy, and it's gravitational potential energy in this instance because gravity is going to pull it down. Potential energy is the highest at the very tip top of the hill before it releases and goes down. So potential is stored, kinetic is movement. Mechanical energy is pretty much the grand total energy that an object has. So it's going to be the total energy of motion, which we know as kinetic energy. And it's going to be the total energy of position. So whether it's sitting on top of a ledge about to fall down, which we know of as potential energy. So the grand total of energy of an object. If we're looking at it as an equation, it's going to be mechanical energy will equal kinetic plus potential. Your examples are going to be like a pogo stick, a slingshot where you pull back and it has all that potential and then you release it to kinetic. A wind-up toy when you twist the wind-up and it's pent up with all of that energy and then finally you let go of the twisty thing and the little toy starts moving. That turns into kinetic, so the grand total energy that object has is said to be mechanical energy. Another type of energy is sound energy, and this one's easy because we all know what sound is. So sound energy is a form of energy that's carried as waves, okay? So it's carried as waves, which we can't see, and it's vibrating waves. So because these waves are vibrating and they're moving, it's considered a type of kinetic energy, because we know kinetic energy is an energy of motion, and because the sound particles are moving, then sound energy is, in fact, kinetic energy. Sound energy is the cause of all the sounds you hear. So examples would be a speaker or a drum or anything that makes noise. Another type of energy is thermal energy, and we understand this as either something being hot or cold. So thermal energy is the total kinetic energy of particles that make up a substance. We know that from our weather unit that when particles are moving really fast, that it's hot, and when particles are bunched together and moving really slow, then that means it's cold. So thermal energy is looked at as the same way. If the particles are moving really fast, it's a lot of thermal energy. If it's slow, it's only a little bit of thermal energy, which can be sensed as temperature. All right? So the more thermal energy something has, the hotter it's going to be, right? So the greater its temperature will be. And also remember from our weather unit that warm always follows cold to share its warmth. Cold does not follow warm. Warm follows cold. And if you look at this example right here with the coffee cup, it shows that you have your coffee in a cup and your coffee is really hot, and whenever your coffee rises up, it shares the warmth with the cold room air, and then your coffee ends up getting cold because it shared its warmth, right? So that's a good way to remember that warm always follows cold. Another type of energy is light energy, and this is a form of energy that can travel through space as electromagnetic waves. And it also does travel as waves, just like our sound energy does. And it's important to know that some objects, yes, give off light, such as the flashlight here, but some objects reflect it instead. And a good example of that is the water. Whenever the sun is casting its light on top of trees or whatever, and that reflection is shown in the water, then water is a good example of an object that's going to reflect light. Electrical energy is the energy caused by the movement of electrical charges or electrons. So if you have electricity moving, that's electrical energy. And it's important because electricity is the main thing we use to make our things work, and we do this through electrical energy. So electrical energy is very useful to us. Examples would be the power lines that supply power to your houses. Lightning is an actual natural form of electrical energy. And then any object that you plug in via an outlet like this would have electrical energy. Chemical energy is the next type of energy, and this is an energy that's stored in matter and it's released by a chemical reaction. A good example of this would be a battery, because whenever you put a battery in something, a chemical reaction takes place within the battery to power that object. Another example would be gas. When you pour gasoline into your vehicles and it starts the motor, there's a chemical reaction that takes place within your car to make your car go. Another example that you can actually relate to from the human body unit is eating. With the digestive system, whenever you have digestion taking place, you have chemical reactions happening in your stomach, and that is a release of chemical energy. Nuclear energy is an energy that is stored up inside the nucleus of an atom. This is going to be like your major nuclear power plants like you see here, or also a bomb could be an example of nuclear energy. Either of those would work. Another type of energy that is said to be the best energy is green energy, and this is because it comes from sources that will not pollute the earth. So examples of that would be solar or sun energy, so like your solar panels that absorb the sunlight to produce energy. Also, wind and water power are great examples of green energy because they do not pollute Earth, but they can still provide energy for us to use. So the last part of this set of notes goes over energy transfers, and an energy transformation is just when one form of energy changes to another. And we know that this happens because the law of conservation of energy states that energy is neither created nor destroyed, it just changes form. So in this chart here we have some good examples. The sunlight helps crops grow, and for crops to grow there has to be chemical reactions taking place within the vegetable to make it grow and get bigger. So an example of that energy transformation would be light to chemical. Another one which we see right here is electrical to thermal, because your oven or your stove has to be plugged into an outlet if it's an electrical stove, and then that provides the heat to cook, which is thermal energy. The next one is chemical energy, which is when your body digests ice cream, which gives you energy to get on your bike, start moving, and then stop moving, which is the grand total of mechanical energy. And then the last example here is chemical energy to mechanical, by you putting gas inside of your car and that reaction taking place to make your car start to move after it's been stopped. Okay? And then the example that hopefully all of you can relate to is charging your phone, because it starts with electrical energy because you got to plug it into the outlet. And then that changes to chemical energy when it's stored, because we get our energy from the battery in our phone, right? So this is the last slide where you guys are expected to give me an example of heat transfers or electrical transfers or chemical to sound transfers that you see happening in this picture. There are tons of examples, but specifically I'll try to give you the easiest ones. The first one you have to do is electrical to heat. So something has to be plugged in, and then it causes something to either be warm or cold. A good example of that is right here, the heater, right? Because your heater or radiator has to be plugged in to produce heat. Light to chemical. A good example of that would be over here, your sunshine. We talked about in the last one how light from the sun helps vegetables and crops and grass and trees grow. So that would be light to chemical. And then chemical to sound. Chemical would be something, a reaction taking place. And then sound is obviously the vibrating waves which we hear. So chemical, typically we can think of things like batteries, something where a reaction is taking place. And alarm clocks are a good example of that, because they are some of them are ran by batteries. And so that chemical reaction takes place to make the alarm clock go off. If any of you have any questions, please see me in class and I will be more than happy to help you.